Hello, this is your first homework assignment on topic 1, lesson 1, types of numbers. Either while you're watching this video or after you watch this video, your task will be to fill in the notes on the PDF that match the video's PDF. So the notes the PDF that's attached where this video link is, you see a PDF that matches it. Okay, so you're going to fill that in, okay? So what do you notice about the numbers in each list that would make some called rational and others irrational? So today we're really talking about the classification rational versus irrational. If you look at the numbers that run in the rational list, there are a couple of things that you'll notice, and I'm going to highlight them for you. First of all, integers like that highlight doesn't work, like -6, 0, and 1. Just integers, numbers without a decimal or fraction part, negative, positive, and 0 included. Those are rational. Decimals that terminate like -6.5 or -1.73. If it's a decimal that ends, it's a rational number. Now, some decimals that don't end are rational. Those are repeating decimals. So if you look at the second example here, you'll see a repeating decimal here. -6.5252 ... So that's indicating that the 5, 2 are going to continue to repeat. That would be a rational number. Also, we can indicate that with a bar, like 1.73. With a bar over it means that the 7, 3 are going to keep repeating. So repeating decimals are rational. Fractions are rational. Fractions are rational numbers. And square roots of perfect squares. So we'll talk about why this is, but like also in this group, you could have like radical. Let me think of a perfect square. Radical 9 is a perfect square. So the square root of 9, which is 3, is rational because the square root of 9 is 3, and 3 is an integer, and an integer is rational. Okay? Rational numbers, the part in green is very important. Rational numbers can be written as the ratio of two integers. And a ratio means comparison of two numbers by division. So if it can be written as a fraction, a comparison of two numbers by division, that's a fraction or a ratio, then it is rational. Numbers that are irrational, they cannot be written as a fraction. They cannot be written as the ratio of two integers. Okay, so first thing you'll see is decimals that do not end and do not repeat. So they are non-terminating and non-repeating decimals. The word "and" should be written here. Non-terminating and non-repeating decimals. So they don't end and they don't repeat. Repeating decimals are also non-terminating, but they repeat. Okay? So they have to be like this example, 0.6532 ... and it does not show a repeating pattern. Or any of these, no bars, no repeats, just a whole bunch of digits. Okay? Pi is an irrational number. Okay? If I go to my calculator now, you'll see over here I have my GeoGebra calculator split screen with my notes. Split screen with my notes so I can calculate things and show you how to use the GeoGebra calculator. So I'm going to put in here radical 10. The square root, the word radical is the same thing as the square root. So they both mean the same thing. Radical 10 equals. Now you see a big long decimal. Does it show a pattern? No. Now it is non-repeating, but it looks like it's terminating on the calculator. Please be aware that this calculator only shows you 15 digits or 13 digits, depending upon what it's set to. Okay? So it will not show you that it's repeating, that it's non-terminating. You have to know that. that it didn't stop and didn't show a pattern. Okay, even though it looks like it stopped. It's kind of a little tricky. If you have a question about that on a calculator for a radical, put a question mark there by the negative 10, by the radical 10, so you can ask me that. Okay, pi is another number that is non-terminating, non-repeating. We know pi has an infinite number of digits. It never stops, and it never shows a pattern. It's been calculated to millions of decimal places, okay? And if you notice here, when I put pi in my calculator, I see it stopping here at this after 9/8, but that is not really the stopping point. It's just the 15 digits that the calculator is stopping at. Okay, the next thing here are the different groups of numbers. Now, I understand that you learned about these in 7th grade. So counting numbers, whole numbers, integers, rational numbers. I put in an example of those sets for you to see the sets that make up those. And you should read that over and review those sets. But I'm not going to go through the whole thing with you because you already kind of have experienced it. What's important here is this graphic, okay, is showing you that right now we're studying all the real numbers. There are numbers that are not real. There you'll get to them in Algebra 2, so we won't worry about them right now, but if you'd like to investigate numbers that are not real, we can talk about that. But the real number system has two separate groups in it. It has rational numbers, this blue group, and irrational numbers. And the rational numbers include all the integers, which are no decimal, no fraction, negatives and positives, and the whole numbers, which are positives, 0, 1, 2, 3, 4, 5, no fraction, no decimal. Okay, so you can follow along with all of this and reread it, and you can fill in those things that are there for your notes. Okay, and a question I want to talk about on Monday's class is, why is pi irrational? It's one of the questions I'm going to ask you on Monday. So make sure you understand why pi is irrational. Okay, I think it's helpful to know your perfect squares because you want to be able to identify which radicals have a perfect square under them and which radicals do not. So make a list of the perfect squares from 1 squared to 15 squared. Now, I did not finish that list. I want you to finish the list. All right, so as part of your homework, you can stop the video now and finish the list, or you can finish it at the end. So you shouldn't be I'm giving you the first 3. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. I want you to go up to 15 squared. And once you've done that, you can unpause and continue the video. Check to see if you're correct this way. We're going to go into our calculator and we're going to put in x squared in the calculator. And you'll see you get a parabola, but I'm going to press these 3 dots that are right next to the x squared. I'm going to press them and table of values comes up. And now it wants to know, what is your start value for x? Well, this wanted us to go from 1 squared. So we want x to be 1. I'm going to back over the -2 and start at 1. And I want to go all the way up to, backspace over that, 15. I don't have to put in the 15 squared. They just want me to know what my x's are. The function is squaring it for you. And the step is asking you, how do you want to skip? Do you want to go by 1s, 2s, 10s, 20s? So maybe if I said, what is something from 1 to 100, the 10s, you would put a step of 10 there. But here we want a step of 1. Okay? And here's the list that should match your list that you wrote here. You can check it. 149, 1625, 3649, 64. These numbers should be familiar to you. Probably until you get to this range with the 169, 196, and 225. Okay? Great use of the calculator there. All right, some questions. Determine if the following numbers are rational or irrational. So you should be able to do this very simply, looking at them by the definitions. First one, 0.125. That's a terminating decimal. The decimal point, the decimal stopping. There's no bar, there's no dot, dot, dot. That is rational. Okay? Radical 7. Radical 7. Is 7 a perfect square? No, 7's not a perfect square. So it's not the radical. The number's going to stay under the radical. If I put radical 7 in my calculator, I'm going to get a non-terminating, even though the calculator makes it looks like it terminates, non-repeating decimal. Radical 7 is irrational. And one of the reasons it's irrational, if you think about it, is, remember what a square root is asking you. What number times itself gives you 7? There is no number times itself that gives you 7. The only numbers that multiply to be 7 are 1 and 7. Okay? So it's not a perfect square. All right. The next, I filled in the next ones. Negative 9 is rational since it is an integer. I could write it as a fraction if I wanted to by writing. Remember, one definition said you can write it as a ratio of 2 integers. So I can write negative 9 as negative 9 over 1. That's a ratio of 2 integers. Next one, 4 radical 5. 4 radical 5 is irrational. Why? 5 is not a perfect square. If you put it in the calculator, 4 times radical 5, you will get a non-repeating, non-terminating, even though it looks like it's going to terminate, and there's a whole bunch of 9s there for a while for repeating, but it doesn't because it pops up back with a 2 again. So it is a non-terminating, non-repeating decimal. And I recognize that 5 is not a perfect square. The number 5 itself is rational because it is an integer. All integers are rational. Okay, 0.333333. That is 0.3 with a bar over it, which, if you know your fractions very well, that is 1/3. Why did I write 2? 1/3. That's a ratio of 2 integers. If I come to my calculator to check that, 1 divided by 3 is 0.33333. Can I write 0.33333 as a fraction? Yes, look, 1/3. That's what that little bar does. It gives you the decimal and gives you the fraction. Notice on 4 radical 5, it didn't give you that option. Why not? On 4 radical 5, because it cannot be written as a fraction because it is irrational. Okay, another problem. Given these numbers, which expression will result in a rational number? So I highlighted on the question rational number, so I want to make sure I'm looking for the right thing. And I'm going to put these in the calculator, but I'm also going to think it through. I'm just clearing my calculator so other things aren't in the way so you can see clearly what I'm doing. Okay, so the first thing is L plus M. And I noticed what I wrote here next to the things. I started thinking about it before I started. What is L rational or irrational? Radical 2. Number times itself that gives you 2. There is none. Okay, that's irrational. 3 radical 3. Also irrational. Radical 16. Hey, I recognize 16 from the perfect square list that we made. That's just 4. 4 is a rational number. So that N is irrational. And P is square root of 9. That's 3. That's a rational number. So now they're saying, what happens when I add these together? When will I get a rational? Okay, so let's try L plus M in the calculator. Radical 2. Now, after I put in a radical, I always have to hit this right button to move over after that, okay, to stop the radical. And I can check to make sure I'm out of there so the radical ends, then my plus sign begins. Radical 2 plus M is 3 radical 3. 3 radical 3. That comes out to 6.610. That's it's a non-repeating, and I don't think it's terminating. Another way I don't think it's terminating is there was no box to show you the fractional value. It cannot be written as a fraction or a ratio of 2 integers, which means it is irrational. So that's why I say no good for that one. This one comes out irrational. And this question's asking me to find a rational. Next one I tried was n plus p. Well, n is really 4 and p is 3. If I add them together, I get 7. 7 is rational. That's why that's the right answer. Now, you might have to check other these other ones. I didn't check them because I found the right answer, but it might be better practice to check them all in your calculator. Okay? Next one, give the following expressions, 1, 2, 3, and 4. Which one is rational and irrational? I calculated them all out in the calculator, okay? So when I want to put a fraction in the calculator, negative 5/8, I put negative 5 divided by 8. A fraction is a division of two integers, okay? So negative 5 over 8 or negative 5 over negative 8. Right arrow to get out of the denominator, plus 3 divided by 5. Enter. It gives me a fraction. A fraction is rational. I can write it as a decimal that terminates, or a fraction, it is rational. So they want to know which one is irrational, so anything with 1 can't be right, because 1 was rational. Number 2, 1/2 plus 1/2 out of the fraction plus radical 2. Gave me 1.91421. No pattern, no box to show you the ratio because it is irrational. Number 2 is irrational. Okay? So this can't be the answer, 3 only, because 2 is irrational. Okay? So now we have to check the next one. The next one, notice this is multiplication here. So this is radical 5, get out of the radical, times radical 5 equals 5. Because it's radical 25 and it's 5. That's rational, which means number 3 is a rational number. So it's not this choice, leaving me with only this one. And you can see I checked on my calculator why 3 radical 49 is rational. The correct answer is choice 1, 2 only. Okay, again, we're going to use our calculator here. We're going to figure out which value for P and W do we get a rational number. Be careful in your reading. We want something rational, okay? So up here, we wanted something irrational. You have to be careful of which question you're answering. I'm going to clear the calculator. You're going to do these on the calculator, okay? The correct answer is 2, and I'm going to talk about this tomorrow. If you have a question on this and you don't know how to do number 4, you're going to do it the same way you did 2 and 3. If you have a question on how I got choice 2, you can put a question mark here and ask me on Monday. I want to make sure this video doesn't go too long. Next question. Is the sum of 3 radical 2 and 4 radical 2 rational or irrational? And remember, sum means to add. So I'm going to go to my calculator, do 3 radical 2, get out of the radical, plus 4 radical 2, 4 radical 2, and add them. And I get this number. Why is it different from the one we got there? This one must be wrong. I don't know what I did wrong here. It's incorrect. I'll erase it, and I'm getting 9.8994949, etc. It's going to keep going. It doesn't show it on the calculator. It keeps going. One way I know that it keeps going is because in my calculator it did not give me a button to press to make it a fraction. It's irrational. It can't be made into a fraction. So I wrote, this is what you have to write to get full credit, to explain. The sum cannot be written as a ratio of 2 integers. Okay, so it is irrational. I wrote irrational. It is irrational because it cannot be written as a ratio of 2 integers. Last question. Determine if the product, now we talk about product, that's multiplication, okay? The product, 3 radical 2 times, oh, I got to go out of the radical sign, don't forget to get out of the radical with that arrow to the right, times 8 radical 18. Comes out to 144. Why do I have this number here, which isn't correct either? I don't know what was happening before. When I did those, I must have made mistakes, which happens. Equals 144. Okay? Now, is that rational? Not 624, 144. What's wrong with me? 144 is rational since it can be written as the ratio of 2 integers. What 2 integers can you write it as? Well, you can write 144 over 1. That's 2 integers in a ratio. Okay, I hope you understood this lesson. If you have any questions, please write them down, and we'll talk about them in class on Monday.